So this lesson is about estimating the area of composite shapes. So you'll remember that a composite shape is a shape that's made up of a bunch of different shapes sort of smushed together. And so before class began, we had a discussion about certain situations where you don't need to have an exact measurement. And so some people mentioned that in baking, if you're measuring the amount of flour, well, you don't need to have that down to the nearest milligram. You can kind of estimate, and it's not going to totally ruin your baking. Another example was if you were trying to buy lumber for your house, you'd probably want to do an estimate and then fine-tune it near the end of the build. Another case would be if you're buying, let's say, if you're getting a quote for carpeting in your house. They're not measuring all the little nooks and crannies. They're just getting an overall measurement, and then they bill you later on for the amount of space that actually needs to get covered. So when I asked people in class if they knew what it meant to estimate, most of them had it pretty much on. So it's not just a guess. It's not a random guess. It's a close guess. It's a guess made on certain basic assumptions. So in the case where you're making an estimate, it's okay if your result isn't exact as it would be in a calculation. So if there's a difference when you're looking at a question, whether you see that they're expecting you to have a calculated answer versus an estimating answer. And so it's important for you to make sure you're reading the question so you can answer what is being asked of you. So I'm going to show you a couple of different methods to estimate depending on the circumstance. So let's look at this first one. So in this example, you can see that the area is fairly well defined, but it's still made up of some composite shapes. And so often installing a grid over top of your object helps you to kind of break it down into smaller pieces, and then you define what each of the pieces means. So in this case, let's say that one square, let's just say that that's equal to 1 centimeter squared. So again, that's just us defining that. So if you were doing a map, it's kind of like creating a scale on a map. So the method I'm going to use for this, because the area is outlined fairly in a straightforward manner, is counting all the full blocks and then counting all the partial blocks, because in this case the partial blocks are pretty obvious and I can add them up easily to get a good estimate. So I'm going to count my full blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I don't think I missed any there, so I'm going to write down that I have 14 full blocks, so that's 14 centimeters squared. And now I'm going to count my partial blocks. So I have 1 half block, 2 half blocks, 3 half blocks, 4 half blocks, 5 half blocks. So I have 5 half blocks, okay? But then I need to remember that is actually going to be equal to 2.5 full blocks. So that will give me an extra 2.5 square centimeters. There we go. So last but not least, if I want to get an estimate, I need to know the overall. So my estimate for the area, okay, if I'm estimating, I'm going to say, well, it looks like it's about 14 plus 2.5, and that's going to give me 16.5. And I'm not going to forget to include my units here, and that's their square centimeters. Okay, now sometimes the shapes are super irregular, right? So it's really difficult to make any guesses about blocks and partial blocks because, the estimate gets less and less of an estimate, more of a guess when the shapes are, the partial blocks end up being sort of not as really well defined. So in this case, what I'm going to use is a different method. I'm going to look at the outer square and the inner square, and then try to give me a range of where the area is likely to be. It might even make sense to look at an average. So let me show you what I mean by that. So in green here, what I'm going to do is I'm going to outline what I mean by the outer square. So here I go, here's the outer square. So what that means is that I'm not doing a great job, but you're getting an outline here, which is that none of the pieces of this shape are going outside of this boundary. Okay, there we go. And if I count this, I can see that it's 1, 2, 3, 4, 5, 6, 7, and then, so it's 6. It's a 6 by 1, 2, 3, 4, 5, 6 square, which is going to give me 36 centimeters squared. Okay, so that's my outer. That means that it's not reasonable to make an estimate that is above 36 square centimeters. That would be way off. Let's look at the inner square here. So my inner square, you know, is basically usually just a little bit inside where the outer square is. I'm seeing that only a small portion of the squares are not completely filled, and that will give me my inner square. So I've got 1, 2, 3, 4. It's a 4 by 1, 2, 3, 4 square, so that's 4 by 4. Oops, except I mean 4, not 5. And that's going to give me 16 square centimeters. So if I really wanted to, it seems like, you know, it depends on the question. In this case, it seems like it's about half and half, right? But I know that an estimate below 16 square centimeters would be not a really good estimate. So a good way maybe to do this would be to take the average of these two. So I say 36 plus 16, get that total, and then I divide that by 2. And that will give me a good average, you know, but anywhere really in that range would be reasonable. So 36, 46, and then 52 divided by 2 gives me 26 square centimeters, and so that would be a pretty good estimate. Okay, last but not least, here's some recommended homework for you to do that I would say is probably a good idea to start to get you comfortable with these ideas and seeing in which situations what method will work the best for you.